Okay, thank you very much. So it's a pleasure being here and seeing some of New Zealand, which I really enjoy, although it's one of this, let's say, Japanese things, see the world in 3 days and do some shopping on the way. So anyway, I'm going to talk about some stuff we've been doing on wearables over the last, say, 15 years. And I want to start by saying something sounds boring, like a taxonomy of wearable system, which essentially is an attempt to span sort of the design space of wearables, which is really interesting for people who may be coming into wearables from different areas of computing technology to understand what are the issues. And then to situate some of the things I want to show you from Europe within this space. So first of all, it looks like a wearable, huh? It's probably not the type of wearable that will win you the C prize. I don't know, but I guess not. But you know, this picture illustrates two very important issues in wearable design. Now, first of all, is if you do a wearable, it's really important to understand why do you put electronics on the body, right? I mean, it doesn't make sense to put this thing on the body, so you have to have a good reason for that. And the other thing is, if you put electronics on the body, how do you integrate it with, let's say, the user's outfit? And those are really the things that define most of wearable technology. And here is an example from my past, a failure from my past, like 15, 20 years ago at ETH Zurich. We built this thing for a German clothing manufacturer. It was a jacket that included, you didn't have smartphones back then, so it was like a PDA, a phone, mobile phone module, a GPS, and then something to control it from the sleeve. So it was displayed at a fashion show. It generated a lot of publicity, but it was not good for anything. Nobody ever wanted to use it. And it's very clear because, you know, why do you want to have a smartphone in your jacket? You have a phone in your jacket, right? Even a jacket, you need another phone. No benefit at all from putting the electronics on the body. So sort of the only benefit this thing had was that we were using at this time raw lithium-ion batteries with some of our own protection circuit, and this thing would tend to catch fire, which was funny. And we did have some, you know, heartburn when those models were in it on running there. So a good example where you didn't think about why to put electronics on the body and sort of how to integrate it. So why do you put electronics on the body? So what is a wearable? So sort of on a philosophical way, you know, what do you wear? Traditionally, you wear clothing. So what is clothing? Clothing, in a way, is a technical system, right? It is. And it's a technical system that has two properties. It's something that you have on you nearly all the time, and something that all the time that you have with you is performing a useful function. Right? A smartphone you have in a pocket, and you use it every 10 or 15 minutes. Your clothing does something for you all the time. And in a way, when you think about designing a wearable system, what you should think about is not as much wearing in a sense, oh, a wearable has to be something that's part of clothing. A wearable is something that has this abstract functionality of being with you all the time and performing a useful function for you all the time, just like clothing does. Or being something and eventually your user will not want to spend any second without. Why to put electronics on the body? If you go from this premise of being always useful, there are three reasons. The first classical reason is to allow people to access information in situations where sort of classical mobile computing will fail. You know, when you're skiing and you want to check, you know, how long is the queue down at the lift, using a PDA or a smartphone in your hand doesn't work. So you have a head-mounted display, or you want to take a call while skiing, or somebody who is doing aircraft maintenance wants to look up the schematics. So things like head-mounted display, different types of interaction are helpful. In a way, a smartwatch is nothing else that is sort of allowing you easier way to access information. You know, if I get a WhatsApp now, if I take up my phone out of the pocket and look at it, you think it's rude. You know, if I look at my watch, you will not think much about it, right? So it allows me to access information in situations where I wouldn't be able to. The second reason to do wearables is to get information to or from the body from very specific locations, right? That's like all this sensing thing. You want to monitor how somebody plays tennis, how he moves his arms, you need to put a sensor on the arm. You want to get pulse, you need to put some sensors here on the chest. And that's something that's very often connected in smart textiles. Very often it's about doing this on long-term basis. And the third thing we started recently is really comes from sort of fashion area. So, you know, I'm a computer person, I'm a nerd, right? So for me, fashion is always like this, you know, blue is good this year, red is good next year, basic nonsense, right? But actually a lot of people pay money for it. And fashion is about expression, right? So it's about being able to express yourself, to send a message to people to look at you. And like classical fashion is static. You know, I put this jacket in the morning and it stays with me. If you put electronics into it, if you network it, then you get a totally new dimension of expression. You know, my system can react to your systems, it can change, and fashion people are starting to realize that, and they're using it. And it's a very interesting area. And you know, on its cynical point, the nice thing about fashion wearables is that you can sell things that don't have to really work and can be expensive. Right? It's sort of a very soft. You set a healthcare wearable, it has to do what it does. So it's actually a nice way to enter technology. So the next question is, how do you integrate electronics in the outfit if you settle for a functionality? And what you need to understand is that, again, clothing is a technical system. And coming as an engineer, it's a technical system with three properties. It's a distributed systems. You know, here's my jacket, here's my trousers, here are my socks, right? It's distributed, and it's distributed for a purpose. I don't put my socks on my hand. They've been designed for the leg, for the foot. It's a heterogeneous system, which means that every component has some very different technical properties, different price point, different technical properties. It's being handled differently. You handle your 100-euro jacket very differently than your sock. So if you put electronics in the sock, you better understand that it will be treated like a sock, thrown on the ground, step upon, whatever, used to wipe the floor if you spill something, right? Which you would not do with a 100-euro jacket. So this understanding is important. And then, of course, it's something that should dynamically reconfigure, which means that if you have a wearable that has something in the shoe and in the jacket in here, you should not require the user to connect it via cables, to configure Bluetooth connections, to spend an hour hacking. It should just, you put it on the body, it should work. And that is how, you know, I say you really need to think about integration in clothing, is that the technological boundary condition of your electronics should be in sync with those technological boundary conditions of your clothing. Right? So if you embed something in a jacket, you have to understand what material is being used, what is the price point, how is it going to be handled, and the electronics has to be in sync with this. A lot of failures in wearables come from not understanding that. Now, if you do this integration, there's one way to think about it, and it's about sort of doing it in 4 layers. I'll just show to you, and then making sure that the components can cooperate across these layers. And then when you optimally dress for an occasion, you optimally have your system. So, you know, you put your bicycling clothes on, you got the electronics for bicycling. You put your party clothes on, you got whatever you need for the party. So the first layer you can think about is what I call like functional textiles. There's actually quite a lot of things that you can do in textiles, especially sensing. You can use textiles for communication. You can use textiles for heating. So if you have something, and in general, that leverages the large area of the body, leverages skin contact, very often it's nice to make it as a functional textile. But it has to be something where the textile has a useful function. Now, for a lot of things, you don't really need functional textiles. You can build a piece of electronics, and now you can build a high-performance computer that's small, right? Build it, encapsulate it, put some plastic around it. It's nearly indestructible. Then sew it into your clothing, and that's it. It's a very nice wearable. And if that's what you need in a lot of places, that is the best way of building robust, complex wearable systems, just by embedding well encapsulated electronics. And then now what you have, we could use inductive coupling, for example, to connect to it and things like that. And now the third category is what I call like attachable peripherals. So actually a lot of devices are things that are specific to body locations, like a head-mounted display, right? Your fitness tracker, things like that. But they do not necessarily have to be permanently integrated in one piece of clothing, right? It can be an advantage. If you put it into this jacket, then it only works with this jacket. If it's something you can clip to your jacket, you can put on your ear, you can clip to your things, then it works with everything. So a lot of things can be done like this. And then down the line, you will always have systems where you can just carry on. You don't need to have them wearable. Right? Smartphone is a good example. Communication modules, a lot of things are much better off if you can just drop them into the pocket and they are not too heavy, they're not too cumbersome. So really think about it, what do you need in integration? What is definitely important is if your wearable has many components, then those things have to configure well, right? So it's just whatever you put and take with you, it has to work as a system that does what it's supposed to do. Okay, so that's like a broad overview, let's say, the wearable design space. And I think that for those of you who have not done wearables, I've been doing it for 20 years, understanding those constraints is really, really important. So a lot of failures that you see is by not observing those criteria. and doing something, oh, it'd be cool to put it in, to sew it into a jacket. Then you think about it, doesn't make sense at all, doesn't work. So let me give you some examples of things we've done in Europe. So first one is this access to information. And that's something that's quite big. So you have smartwatches. There's a lot of industrial wearable computing in Europe. A lot of it goes back to a large European project, what is called Wear It at Work. It's been, I think, 10 million or something euro done nearly 10 years ago. And it worked with companies. And at that time, they're trying to putting head-mounted displays, gesture-based interaction, into industrial environments. At this time, it was struggling. There was a lot of issues with labor union. People weren't comfortable with it. Today, people see it very differently. They're used to having electronics on the body. And actually, it's interesting, also to see the time horizon. So the project finished in 2009. And like about 2 years ago, you've really had begun to have companies that use this. So that's one of the German companies that does very successful wearable applications, and it's something that's being deployed now in Germany by a lot of big companies, BMW, Volkswagen. They have this sort of wearable computing in, let's say, still trial phases, but with hundreds of devices deployed on real factory floors. So there's a lot of happening here. Here's an example of sort of what it does.
Now the order picker can easily log in and begin picking by scanning the next available trolley. Using Ubimax's innovative user interface, task information is displayed clearly in front of his eyes. The trolley is also displayed graphically, so that the picker sees instantly what needs to go where. This could provide a much faster, more accurate, and user-friendly approach to order picking compared to standard paper pick lists and handheld scanners. Our first pilot.
So that's something that really logistics is a big application area. In Germany, this wearables in industrial is embedded in the context of what you call Industry 4.0. Some of you may have heard it. It's like a big initiative in Germany. And if this picture is confusing, then that's the point, because the whole thing is slightly confusing. As many government programs are. But the general vision is that what they want to do is to put Internet of Things, intelligence, sensors, connectivity into production, into individual machines, to make through that production processes more efficient, do things like predictive maintenance, being able to customize products. And it's currently in Europe, it's a multi-billion-dollar research agenda sponsored by governments. And within that, wearable computing, industrial wearable computing, has become a very important part of the program. And there's a lot of work on it. If you look Industry 4.0, you will find a lot of applications now, and it's really a big thing in Europe. So now let's go to the next thing, this getting information on and off body. And for me, a lot of it is connected to textile electronics. So that's one of the EU projects I've been involved with. And the vision we have been looking at is, sensors on the body, smartwatches have become really mass products. If you look at smart textiles, you don't really have mass products, right? It's things, somebody does something in the lab, small company does something, and it's cool. And one of the reasons it is so is that today, when you do a solution based on smart textiles, it's mostly a dedicated special purpose solution vertically through all the production chain. So there are very few mass-produced components that you can leverage to build those things. I mean, that's what we had with this. That's why you see these apps here. It's sort of like if you look at wearable applications, mobile sensing applications, where they took off is when you had a smartphone as a mass-produced platform that everybody had, and all you had to do to get a new application was to write an app on that phone. When I started Wearables, and you wanted to do some sort of a sensing application, it really involved building complex, elaborate hardware for every application, and it was not something that would take off. So the idea is, can you do something like this from textiles, like a general purpose sensing? And the vision was that you look at production of fabric, and you would do some sort of a structure into the fabric that can be leveraged to use various flexible types of sensing. And then just use these fabrics to build T-shirts or whatever. And that would not necessarily do anything yet. They would just be like a sensing or intelligence ready. And it would then really be the electronics that you connect, analog digital electronics that you connect to this fabric that would determine the functionality. And it would be just a matter of writing proper software to leverage this mass-produced general type of sensing to do an application. So it's something we experimented with. And here's one of the things we ended up doing. So what you see here is a piece of textile when you have on 3 layers. So one layer is on vertical conductive lines. The bottom layer is horizontal conductive lines. So that gives you like a matrix. And what's in the middle is essentially piezoelectric material. So when you press it, it changes the resistance. So essentially, you get a matrix of pressure switches, right? Just like a button. Matrix of button that can measure a pressure that you can read essentially by horizontal and vertical thing. Important design consideration for textiles. By doing it as a matrix, you limit the number of I/Os that you need from the textile. Getting connection to a textile is a major pain. So you want to limit the number of I/Os. So matrix reading is really good. And here are some things you can do with it. So that was actually done for a German competition, a Telecom competition. So we put it into a shirt. So the thing has been put into a shirt.
Hi, I am David, your personal coach. Let me get to know you. Now stand still. Move your left arm to the front with your chest muscle twice. Now put down your arms, and curl your right arm with your bicep twice. Perfect. Let's start with push-ups. Get ready. Starting in 5, 4, 3, 2, 1. Start. Slow down. Go deeper.
We put this fabric into the shirt, and what it does is by this pressure metric picks up shape changes in your muscles. And obviously shape changes are related to muscle functionality. I look at the bodybuilders, they do this, and then you get a big shape change. And what we did is we tried different other things with that fabric. So we used the very same fabric that we used in a t-shirt, we put in a leg band. So now it was a much smaller one that was put into Bandages. We're now talking to companies actually that do like bandages and to measure pressure. And then you can look at very simply at muscle functionality on the legs. So you can use that for example for these machines in the fitness room. But where we found it useful is, for example, for bicycling. When you do bicycle, you have to push and pull. And the pushing and pulling is done by different muscles. So you can actually see that in that sensor. You wouldn't see that if you looked at a motion sensor. And here's another application, again, of the very same technology. So we again took the same textile technology, and instead of, let me just switch off the stupid music. And instead of putting it on a body, we put it as a large area in something like a yoga mat. So now inside this yellow thing below it, you have a large matrix. And now you can do a very different type of monitoring. And again, in terms of a basic textile thing that you're using, it's the same thing. It's very much the same electronics, it's just a larger area. And again, if you think about using what you mostly do in wearables, which is like motion sensors, a lot of the exercises are difficult to monitor because they are about balance and contact with the surface. Here's another fairly exotic application of the same thing. So now we have put this small pressure matrix into the side of your bicycle or motorcycle or skiing helmet. What you can now do is you can use your tongue to sort of control the cursor and click. It sounds strange, but actually when you're sitting on a bicycle or skiing, it's not such a bad thing. Try it. There's some subtle tongue movements. It's getting used to, but actually it's not a bad thing. And again, it's very, very much the same material. And there are many other applications. We did this project with car industry, or putting into car seats. That is that soccer shoe where we put this material, smaller patches on it, on the surface of the shoe, to be able to, you can actually now buy soccer shoes when you analyze the motion. But if you want to understand how you should, you have to combine the motion with actually the contact information. I can move my feet. If I don't hit the ball, it doesn't fly. So that is actually a relevant thing to do. Now, one more example I want to show you. So that's a different type of sensors. So what you see here is a much simpler thing. It's just a piece of clothing, and on this we just put textile electrodes. So they are inside there, shielded from galvanically, and they work like a touchpad. When you have your touchpad and you hover your finger above it, it will sometimes react, which can be annoying. So now if you have like this touchpad in this thing, and you put it in a collar, you sort of can look inside your neck. It's sort of like poor man's X-ray. And what you can do here is, so you have a Jingguang, she is the postdoc who did a lot of this work, have it on her neck, and you can detect things like chewing, swallowing, coughing, laughing. So what we're looking at is actually nutrition monitoring. You can imagine, instead of paying $100 for a diet, you buy this thing, and every time you swallow a chocolate, you get like 220 volts somewhere. That's a good product. No, seriously, I think if you look at an ability to understand your nutrition habits, how often do you eat? If you eat like slowly or swallow quickly, right? And you have like with elderly care, there's the issue actually of hydration, people drinking enough. So, and it's a very nice unobtrusive sensor that you can put there. And it gives you a lot of other information, things like head gestures, swallowing, chewing, what are you swallowing, coughing and laughing. So a very simple textile capacitive sensor, although actually processing the information from it is not trivial because it does pick up a lot of noise. It's sort of one of those sensors that senses everything. And once you sense everything, picking up what you need from everything is non-trivial. So you can also use it on actually even on the wrist to pick up things like breathing and your pulse. The reason for it is that when you breathe a lot, you change the capacitance of your body. So that's quite interesting. So now I come to sort of the last part, which was the fashion thing. And I was always in this wearable computing community that looked at taking computers and computing hardware, putting it into your body. I recently got in contact with a large community that comes from the fashion. So those are fashion people who are trying to put all sort of blinking and other stuff on clothes. And there's actually a big scene in Germany. So Berlin is a big place, and they have things like a Berlin Fashion Week. And as part of the Berlin Fashion Week, there's what they call a fashion tech, which is an exhibition, just to give you a taste that looks in wearables. And you can see it's not a techie thing, right? It really is about fashion, and they put all sort of things that look cool using some sort of electronics. And what you really see now as an interesting development is that you see a convergence of this more like a technically driven wearable scene with a fashion-driven one. A lot of this fashion thing previously were technically very, very naive and stupid. And a lot of stuff we did as computer scientists were from the design point of view, very stupid. It's like suddenly you realize that you have to get other people that your own computer science students to wear it and use those things. And when you want to do that, you need to involve design. So there's some really interesting, some of the things are not really usable. It's more like, haute couture to what they do there, but eventually it's going to mass production. Here's another thing that's been done. That's been something that's really very much like the C prize. So it's been done in Germany by Telecom, the brand, and they sort of had also a competition, which actually is being run again this year, where they asked most of the designers, engineers to suggest, some wearable projects, and they were very broad. So in this competition, I was also involved in it as a judge. They had, for example, one entry when they have a 3D printed dress that involve 4 landing pads for drones. And the idea is to synchronize the dancers' dance with the drones, which didn't work really well because they were not technicians. So they put some sort of an indoor tracking system that worked very well in an empty room, but didn't really work that well when you had like a showroom and everything. So the dancer had to wear like a special helmet. But also they had other things. So they had really very, very technical solutions there. So let me show you one very nice solution, and that's my final example. I think this is a very good example of brilliant wearable design. So what those guys did, they said, you have a lot of people who would like the smartwatch functionality, but somehow they cling to their useless mechanical, expensive old watch, right? I mean, for the Swiss watches, you pay a lot of money to get something that works well using technology. They're not suited to doing it, like mechanics, but it's still expensive. So instead of replacing the watch, what they do is they say, you put the smartwatch functionality on this armband, so you can attach it to any watch. And in terms of this question, why put electronics on the body? Because you want a smartwatch, but you don't replace the watch. You augment what people already like. This placement on the inner side has a lot of advantages. First of all, it's more protected. Second, people don't see every message that you get, like you do with the iWatch, with the Apple Watch. You can use the band for things like battery and cables and something. So that's one of the groups that took part sort of on a very, very engineering, well thought through design. And on a final note, what I found really interesting, and maybe people who experienced also with the C prize, was that during this challenge, in the end, during 3 months, the groups like, the guys doing the drone-enabled dress and the engineers doing this sort of stuff, working together in a single room. And the interaction between this very, very diverse group has been extremely interesting. In the end, although they were competitors, they ended up helping each other, and you're learning from each other. And I think this is a big thing. In the end, you have these 10 groups coming from very, very different backgrounds, And when you do wearables, it's important to have very different backgrounds, can learn from each other, and very interesting things can happen. So hopefully you will all submit and then build absolutely world-changing, galaxy-saving products. Okay, thank you very much.